Well, excellent. Thanks everyone for coming. I firstly want to acknowledge that you've all relatively sat in the middle of the room. I don't exactly know how it works. Sometimes you can have a group, and if there's far more seats than necessary, there's just a different vibe. You'll get this person over there, you'll get a person in that corner, and then I feel like I have to go and herd them like cats. Come on, you can move in. But you're awesome, so I really appreciate that. We're in the middle, and I want to share something that I have benefited from since I started using Cloud Foundry 2012. I started Stark Wayne 2012, 2013. But really, before Cloud Foundry, I was using Heroku, and so I've benefited from things like build packs for over a decade. And I think it's because Heroku and Cloud Foundry have always made sense to me. I've never been very good or enthusiastic about evangelizing it, what we're going to talk about now, because what's to talk about, it obviously makes sense. You know, let's talk about the hard stuff. So I'm actually doing something. I did a YouTube video earlier in the year, which I think was still one of the first times I've ever really said, all right, let's play with Cloud Foundry. Because I always just assumed someone else would do it. But, you know, you've got to have your turn. So I use Cloud Foundry. I CF push all the time, and I'm happy to share it. So if this is your first time, then you're going to need the CLI, and I'm going to do these commands for you. This is not a hands-on lab. But there is the CLI you're going to need to install it. There is a new one coming out, and for anyone watching the video, at some point in the time, CF7 might be the one you get, but the instructions and the commands, I believe, will keep working through CF v7. Now, we are going to talk to a Cloud Foundry. So Cloud Foundry is fundamentally a running system running somewhere else, whilst we look at it through perhaps the eyes of a command line tool. It is actually talking to a hosted service running somewhere. And we're going to log into that. Now, I will come back to this slide. If you're looking for a Cloud Foundry, here are 6 of the sort of certified Cloud Foundries. I guess cloud.gov is probably just for government people, but the others are all where you could get a free account and get started. And we're going to use one of those. And then there is, of course, there is CFDev, and CFDev is where you can get a whole version of Cloud Foundry running on a suitably sized laptop. Cloud Foundry is not a small thing, but it can run all on your laptop, and that is super cool. It's also, it builds it and runs it the same way that many people run it in production, which is using a tool called Bosch. So later on, if you become interested in how it works, you can start playing with it all on your laptop, which could be quite kind of interesting, none of which we're going to do today. Today, we are CF pushing like champions. So back to login. Now, I mentioned login because there are a few different ways to log in, and I do want to highlight the one that I use because I'm the speaker. And we're not really running an opinion poll here. So there is different ways. So now I've just copied the output from if you run CF help, but there are a bunch of flags. And so if I'm going to, for today, I'm going to use pivotals, in part because it's been out the longest. I've just used it the longest. I want to always. Sometimes I don't think enough people give enough respect to Pivotal for all the money they've spent on Cloud Foundry. So today I'm going to use Pivotals, but everything we do should work very similarly in all the others. All right, so I'm going to log in. And typically, I have in my history this command, or a version of it. So it's got the -a flag, which is going to point to which Cloud Foundry I'm going to talk to. Maybe I'll specify in an organization the -o flag. My account happens to have a couple of different organizations, so I'm just sort of short-circuiting, and I already know what space I'm going to go into because I've done this an hour before it turned up. But the most interesting one here is the -sso flag. Many people might never have even tried this flag, and what this means is I'm not going to put my username and password into my terminal. So when I run this, I get given this URL. I'll just pop that up. I've already logged in, so I feel like I might have short-circuited something, cheated you out of. So normally you would need to log in, and Pivotal's got their UAA configured this way, so I need to first, yes, confirm that's the account. And the reason I like the -SSO flag is I get to use one password in my browser, and I just feel a lot more secure about this process than having my password in my history. I get this, copy and paste that into there, and now I'm logged in using two-factor authentication. That's my process. I like that. It means I'm not sort of lured into putting my password in my terminal because it's fast, and we're logged in. So the next thing we're going to do is deploy an app, which is the literal title of the talk. So I don't want to leave that till the end like it's a big surprise. In order to deploy an app, we need one. Now, this is where everyone will have their own favorite language. Not many people are probably doing multiple programming languages regularly. So I will be wrong for 90% of people, depending on what language I pick. So I'm just going to live with it. I'm going to pick Ruby. I like Ruby, and it's small, and it's easy to look at, and there's not a lot of things, and you'll go, oh, different languages, how cool. Because if you can deploy if you're a Java person and you can push a Java app, well, now that the deploying part is taken care of, you can now start to dabble in other languages just because it's, the deployment part's easy. The only part you've now got to figure out is what does a Ruby app look like? What does a Node app look like? What does a little Golang app look like? So I've made a little app, and I've put it at a handy URL so I could remember it. It's just a gist, that's all it is. So you can sort of see it's just goes to a gist that I've pushed. It is literally tiniest little app you could imagine. I have a dependency. Gem file is the Ruby equivalent of package.json for JavaScript or Node.js, POM, there's a list of dependencies. And my app is in this config.ru, a super tiny little app. I mean, even if you don't know Ruby, you can figure out what this does. And right here, it's going to say, hello world. That's what we're looking forward. That's, because it's an app, and every app should say hello world until you have a reason for it not to. So, hello world. All right. Now, ideally, I should be able to run my app locally, even though it's truly my belief that you want to get off your laptop as quickly as possible when you start a new project. There's nothing in our profession where it works on your laptop but doesn't in production. There was a very funny Twitter message once that was a joke where the sysadmin had come to the developer and said, it doesn't work, and the developer said, it works on my laptop, and the sysadmin said, well, then back up your email because that's gone into production. So we want to get off your laptop and want you just to live in production. But first and foremost, you probably want to run it on your laptop. So let's show you some Ruby things that you'll never type again. This is the equivalent of yarn install or Gradle. Just pulling down dependencies. That created a little lock file describing all the dependencies that I want. And then we're going to run the app. This is just, again, all Ruby things. That if I'm a Ruby developer, I know these things. But, and if you're on your language, this is just your local stuff. But what we're going to look at soon is Cloud Foundry knows this stuff too without me even telling it. Okie dokie. So let's run my little local app. What did I put it on? 9090. Don't know why I did 9090. That is not useful. But there's our app working like a champion. All right. So I needed to know all that stuff. I needed to know the Ruby way of running apps. I needed to type it. But as we move on to pushing an app, we'll discover that we don't need to know this stuff. Cloud Foundry and build packs know this stuff for us. So now CF push. Let's just make this a little clean. CF push tiny Ruby. Just need to give it a name. Now, this is a name that's specific to the space that we're in Cloud Foundry. I'm not going to cover orgs and spaces, but I do need just to give it a name. And that will attempt to give it a route, but let's just go with a random route. There are many flags, and we'll look at some of them. So the first thing it does is sort of generates a random route that is available. It uploads the code in this folder. There are ways to ignore files. So if you've got like a big logs folder or a node npm, node modules, and you don't want to upload those, there is a .cf ignore file that you can use. So you really don't want that to be a big thing. You want the smallest possible thing that's faster. Now look at this. This is super interesting. This is, you know, whilst Cloud Foundry does a lot of great stuff for you in day 2 onwards, this is fantastic. This business of you just give it some files and it goes to all these things called build packs and says, hey, which of you know what this is? And so it asks the Ruby build pack at .NET, Go, PHP, static file, Java. It asks all of them, and the Ruby build pack is the one that says, I know what that is. Now, specifically, the Ruby build pack looks for a file called gemfile, and gemfile.lock, and it says, well, if you've got those files, I assume the rest of it is a Ruby file, a Ruby app, and I've got that. If it found a package.json, it would say, then the Ruby app would probably ignore it, a Ruby build pack would ignore it, and the Node build pack would pick it up. And so build packs are this way of a plug-and-play way of making Cloud Foundry as flexible as we need it. So if your organization wants to start playing with Rust, and there's no Rust build pack, okay, you can make a Rust build pack. There's probably 3 of them on the internet.
So what would happen if my file structure is a bit bigger so that two build packs would say, hey,
That's a good question. The question was, what would happen if arguably 2 build packs would match to that? Like a Ruby app often, a lot of apps will have some Node for the style sheets and things. And it all comes down to ordering. This is, in this Cloud Foundry, the list of ordered, so they're actually done in that order. But if that order doesn't suit you, you can actually be specific and you can say, this is the build pack, and I will do that soon for you.
So it basically means first one wins.
First one wins, yep. All right, did we deploy our app? We did, look at that, go us. So there is the URL. And there's our hello world. That's our hello world running on the internet somewhere. Don't care where, you know. The last thing I care right now is where it's running. It works, and this is pretty fantastic. You can see that there is the start command that it decided for us is going to work for us. Interesting that it's allocated as 1 gig of RAM, and yet it says I only need 25 meg of the stuff. So perhaps we can look at optimizing that in a moment. So when we push, we can give more suggestions. As I said, by default, it allocated a 1 gig container of RAM. And the reason it over allocates is because bad things happen when you run out of RAM. Things just die when you run out of RAM. So Cloud Foundry by default allocates a lot of RAM, much more than nearly every app will ever need, and it's left to you to scale that back down to the size that your app will be happy with. The -b flag allows us to be specific about what build pack or build packs we want to use. And it's probably a good idea to start with 2 instances. Now, obviously that means you've got twice as much, you've got cost something. In some way you're paying for this. But if you don't start with the idea that you've got 2 containers running, and they don't share memory, they don't share disk space, that way you'll be forced into that realization that this is how things scale in the cloud. So starting with 2 means that you start with this idea that there's no shared memory, no shared disk, and don't pretend that that's the case. So let's play with those flags. So we had our CF push. Now we already have allocated a route, so we can drop that now. We can do -build pack, so it was called the Ruby build pack. We want 2 instances. We can pick any number, and memory is 256 meg is going to be plenty. And it would push that app again, and it'll give a visualization that we've changed something, and it will go through that process. Now, when it does this a second time, even though it's a tiny app and it did very little, it does it even faster the second time because it starts to cache some of the decisions it made along the way. Because we did not change the dependencies. Now, you're not a Ruby person, but we have a library called Sinatra. I did not change what version of Sinatra. I did not add any other versions. So it does a really quick job of just saying, I'm just going to use a caching layer and drop those straight in. Which, when you start to get lots and lots of dependencies, not have to fetch them all from the internet a second time, a third time, is super handy. So now we can see we have 2 containers, and each of them uses only 256 meg of RAM. And it no longer did that, it only looked for the Ruby build pack, which solved the problem of if they picked in the wrong order. And of course, we want to make sure it still works. It is on that idea of multiple instances. If you've got more than one instance, the traffic is randomly allocated. So should each of the containers behave differently in some way, different traffic will go to each one. And sometimes people like to do little demos where they'll print a number and it proves something. But just to be clear, we've now got 2. They don't share memory. They don't share disk. Please don't write to those things. All right, now, even though the cf push command did all that magical stuff, it gave us a large amount of RAM that we then explicitly came down and said we wanted less RAM. It only did 1 instance by default, even though 2 or more is better, and it didn't decide on any build packs up front. It figured that out during staging. There were flags for all of those things. But I would ask you to then move on from flags and to create a YAML file that describes these things. It gives you some benefits later on that we're not going to get to, but it is more explicit of what it is you want. And it allows you to document perhaps what staging app looks like with its URLs, and perhaps what production app looks like with its URLs, and perhaps different environment variables. So there is a command. We could write it's a YAML file, and since none of us know what the schema of that YAML file is, they very helpfully made a little helpful app, a little command. So the create app manifest command takes the app that's already running and spits out the YAML file. And then we can commit that in our app, and so now everyone knows how we deploy this app. So that's an example of a manifest. And in there we can put environment variables, so we could add build packs, and we can make changes. So let's do that. Let's now, before I do that, so now we don't need to, if we look at CF help, we'll see that, where is F? Minus F, path to manifest. And it doesn't say the default, but the default is what we have. So now I don't need to do anything. I can just do CF push. It automatically finds the manifest.yaml and automatically pulls in all those values, and off it goes. So let's make a change to that. Let's go 5 instances, and let's add another route. Anything else good? Ooh. No, that'll do. And that manifest.yaml can be quite handy if you need to produce it during CI based on any inputs. Secrets, inject secrets in there. There are things you can do with variables, and lots of other little things that we would learn in subsequent talks. And off it goes. So it's added that new route. It's going to change to 5 instances, and it will keep going until it finishes. All right. Really nice thing about, given that it's a big multi-tenancy thing, and like this Cloud Foundry is not run by me, it's run by someone else, I can't just jump onto one of the servers, rummage around looking for my container and start looking at its logs. Cloud Foundry is fundamentally a multi-tenant experience, and so all the things you as a developer or an operator need to do, it brings those to you in a safe and secure way, logs being one of them. So we have 2 ways to do logs. Not exactly sure why we have to have 2 of them, but nonetheless. CF logs tiny Ruby. So CF logs are name of the app and recent will give you a collection of logs across all the app instances from some period of time that's got in its cache. If you want like big history of logs, that's where you would plug in third-party logging systems, Splunk or some of the hosted ones. So you can sort of see that we've got here container number 4, container number 1, container number 2, container number 0, all starting up, so they all look like this. It's in red, but there's no error, but they're all just starting up. The other way we can do logs is we can tail the logs, which is the default command. So from now on, any new requests coming in, any new logs that get spat out from the application containers will show up there. So there you go. So we get to see the sort of request metadata for that request and any of the application logs. Noteworthy, one of these is white, one of these is red. That is helpful unless you are red-white colorblind. But it is the standard out and standard error. So let's have a look-see at our little app. So there we go. So this is Ruby way of saying print to standard out, and this is the Ruby way of saying print to standard error. And this is noteworthy because you might have previously written to log files. So in Cloud Foundry, log files will get written and they'll be sitting on the file system, but we don't have a nice way to get them back out. The way we do logging in Cloud Foundry is you write to standard out and standard error, and they will be consumed and fed back to the user or to the external log system. Sometimes it's just a matter of a configuration change. You just write to your normal logging system, but you just change that logging system to be standard out, standard error, rather than a file. Okie dokie. Now, another really nice thing about the CF command line tool is that, so we saw that we could plug and play with build packs. Another thing we can plug and play is with plugins. Plugins are a personal experience change. Build packs are shared by everyone. Plugins are just you locally. And so if we go, what do I got? I've written one or two of these myself over time. Lots of different plugins. Sometimes they're for point in time, but we have some interesting ones around, view all the different build packs being used. Helpful to figure out if anyone's using older plugins, build packs, and we need to help them update. Doctor, just look at the apps and see if there's any errors. But the one I want to show you that might be one of the first ones you might want to load is called Open. The CF CLI does not have a nice way just to open an app into a browser. Plugins are a really simple way. And we wrote it was one of the first plugins ever written, was like, well, we just want to open something. But I thought it'd make a good demonstration of, barring slow internet, would have made a great demonstration. Look, it's already installed. And this particular plugin goes into the app, finds out that it's got 2 routes. I'm not sure why we chose to show them and pick one, but pick one, and then it will throw that up into the browser. And so it can be a convenience helper. Okay. Now we will come back to that plugin because it also helps bring up service dashboards. But it's like there's lots of plugins. There's 80 or so, and they're pretty easy to write should you wish to extend your experience. Now, applications, we talked about that applications, if you write to disk, you will be sorely disappointed when later on the contents that you wrote to that disk aren't there, because the life cycle of the container and its disk is unknown. The Cloud Foundry makes no promises of how long that container will last for. Personally, I like if you made no assumptions that container will be there 24 hours later. Do not assume that your container will become more efficient over time with caching and things like that. Try to avoid that. any caching, any disk, any persistence you want to do outside of the container. And the way that we do that, and maybe make that convenient, is with a marketplace of services. And this is where everyone's Cloud Foundry starts to become a little different from each other, because it depends on what your Cloud Foundry and your platform team want to offer. Things take time and money, especially data. You know, the moment you start writing to a database, you assume that someone's looking after it, someone's backing it up, someone's going to provide services. So they might not want to provide every database known to society. They might just want one SQL database, one message bus, etc. So the way we find out what we've got is with CF Marketplace. And unfortunately, the Cloud Foundry I'm talking to actually has a lot, and they can take a little time to display. So they'll come back to that. But here is an example. They have one called Elephant SQL, which happens to be Postgres. There are some different plans. Turtle is free, and I've got to be honest, I'm a sucker for free things. Deep down, there's a university student in me that still wants free stuff all the time. And whether it's a sausage and bread or it's a free database, I'm in. You know, stickers, whatever. All right, and not only do they have a lot of them, they don't print very nicely, but there's lots. But yours might only have a few. So they have different names and there's different vendors. So there's lots of different people in the Cloud Foundry community who can provide your platform team with a database that you might want. So it's a conversation. This is where you go back to your platform operator and say, hey, why don't we have Postgres? Postgres is awesome. And they say, we like MySQL. You go, no. Anyway, they have a really adult conversation like that. I want it. You can't have it. Like children. Anyway, so let's create one. Let's make the font bigger again. Create service. So little command, create service, and we'll just give it a name, DB. It's a good name as any. And what this is doing is it's the command line tool saying to Cloud Foundry, I want this database. Cloud Foundry, it's plug and play again. It goes off to what's called a service broker, a bit of internal, teaches something. And the service broker has that abstracted understanding of what is this request. So there is like an Elephant SQL service broker or equivalent. And it gets the request and says, got it. Let me go and create one of those for you, whatever that thing is. In this case, a Elephant SQL Turtle plan is like a shared database on an existing Postgres cluster, I think. I didn't write it. That's just my understanding of what they did. So now it exists, but we can't use it yet because we haven't got username password. So in Cloud Foundry, that's called binding. So we bind the service to our application, tiny Ruby. Now, there's another request that goes from the command line tool to Cloud Foundry, and Cloud Foundry forwards it on to the service broker, and the service broker takes it and says, a binding, I can do that. In Postgres, that means creating a user, perhaps creating some roles, and generating passwords, and then returning them back to the Cloud Foundry, and then back to the user, or to the application, sorry. And now it exists. So if I now restart my app, you might think, well, what exactly does a Hello World app do with a database? And that is an excellent question. It does nothing with it. Nothing about what I just did makes an app know what Postgres is. So your application still needs to know what Postgres is, how to talk to Postgres. What we have done so far is create one and make it, give it credentials. And then we'd have to add Postgres support to our app. Good question. You would have noticed that up here, when I did the bind command, it said, use CF free stage, and then I didn't. Like a champion, make my own path. I'm going to do what the command line tells me. So, which leads to the question. The question was the difference between restage, which it told me to run, and restart, which I ran. So restart takes staging. When we did push, we did CF push. That long process of discovering it was a Ruby build pack, pulling in a version of Ruby, pulling in a version of Ruby gems, pulling on the gems and everything, and making what we call a droplet. That's called staging. And then we take that, it's like a Docker image. It's our own internal interpretation. because we exist longer than Docker does. That's called a droplet, and then when we start the app, we basically just run copies of that droplet. And so restart basically says, just take the last droplet, it was good enough, just start it again, but with new environment variables. Restage goes back and says, take the source code we already had and just do that build pack thing again, and then restart. And now the reason that it suggested restaging is because it's more likely that it will cover all edge cases. But pretty much most apps don't need restaging just because some environment variables changed. So it's like an old idea of Java apps needed to create config files and whatever. I don't know how many use cases there are for restaging. But thank you for the question. So my app is still a hello world app. It still doesn't know what Postgres is, but we have given it Postgres, which leads to the last thing, which is SSH. So we've got logs, we've got databases and message buses and email and all different services. We've got scaling. And yes, there are more commands. You don't have to use CF push for all these things, but we only have 30 minutes. And this is SSH, the last thing I want to show you. So I have 5 application instances running. I'm not going to SSH into all of them. It's going to put me in one of them. If you have a specific need to get into others, you can do that. All right, so here we are. Now, this is all gobbledygook. And I'll come back to why that's gobbledygook is there. This is doesn't look anything like my app. But what is useful right up front is the environment. And this is all the different environment variables that were provided to our app. You might like to use some of them. Noteworthily is port. That's the port that your application should bind to in order to receive HTTP traffic. Cloud Foundry does do multiple ports and other things, so they might be provided somewhere. You can look up, there's one called Echo VCAP application, I think. And it includes the URLs that were bound to your app, so that can be useful because sometimes you might want to provide those back to users. What is my URL? So you can dynamically look that up. The one that we just looked at was services. So how would we find what that Postgres that we were just given? It's provided through this VCAP services environment variable, which is this big JSON object. And if you have multiple, if you have an email and a Postgres and an S3 bucket, it'll all be in there. And it's your application's responsibility to look through this and find credentials, which we can see here. And so anyway, your application will probably do this in memory, but JQ is also on the filing system, so you can sort of do that as well. But yeah, your application, and most languages have a Cloud Foundry library that's good at parsing this thing. I can't think of a language that doesn't have one, and if you have got a new language that doesn't have a nice library for parsing this, let me know and perhaps we can find it, perhaps we can write one together. This Temp Lifecycle shell, I actually have it as a snippet. And what that does is now puts this in the application. Anyway, there's blog posts about this, but that makes sure that you've got everything that your application expects. But I feel like that needs more introduction, so I wish I'd never mentioned it. And we talked about that. I will just show one little example. So we run Ghost, Stark and Wayne, we run Ghost as our blog. We run it on Cloud Foundry. In order to set it up, I needed to take the bindings that came in and create a JSON file that Ghost would use to load it up. So rather than fix it in JavaScript at runtime, I just generate a big, and so we actually parse this thing at start time. So if your application has a .profile file, it is run before every container is run. So it's a great way to generate config files, anything at runtime. So I mentioned it as an example. I have had to look in this VCAP services, run it through JQ, pull out values, create config. There we are, look at creating a big JSON file, config file that Ghost wants, rather than go and modify Ghost just so it runs on Cloud Foundry. So the dot profiles is a great solution to how do I generate config based on at runtime. And that's it. I hope if you don't have a Cloud Foundry already, each of these has a free plan, or at least you can sign up, possibly with the exception of cloud.gov. And there is not just my video, but many other getting started videos. And if you have any questions now or later, please ask. Thank you very much. We had some lovely questions already. If anyone else has one, you may ask it.
Two things that you might ask me. One of them, very early on, you referred to the difference between the staging environment and the production environment.
Yep.
And then later on, you talked about
Staging an app. Oh, I appreciate that. They are two uses of the word staging. Cloud Foundry has not, so I say staging and production. Hey? Good question. So the question was, I used the word staging twice. Once I said staging and production, it's like a pipeline, and later on I made reference to when we talked about restaging, that the CF push does a staging process. They are different uses of the word staging, and for that I apologize. And so once you start deploying apps, once you realize how easy it is to deploy an app once, why wouldn't you just deploy it a second time and say, well, the first one's our one that we always deploy to, and once we're happy, we can deploy it again to production. And perhaps you want to start deploying off branches. And you can do anything you like. It's so easy to deploy and create new routes and delete, the CF delete, and you delete an app. So it becomes really easy to start imagining an entire pipeline of deployment. And so I apologize. I would, say staging, test, whatever, and then production is what I meant. And that is not a concept that Cloud Foundry has formally. You would make that up yourself. This app is my staging app, that one's production. It really is a function of what people use it for. If no one knows about the staging app, that's the staging app. The production app is the one people complain about when it goes down. And yes, then I use staging or refer to the build pack process. I apologize. Good pickup. Sorry about that. Cool. Well, thank you very much.